Hello everyone, my name is Jagandevasan. My topic for today's video is firewalls, their concept and role in network security. This topic falls under the broader area of network security and cryptography fundamentals. In a world where almost everything is connected through internet, network security has become one of the most crucial concerns. A firewall is one of the earliest yet still most important defenses we have against cyber threats. In this presentation, I will walk you through what is firewall is, why it's needed, how it functions conceptually, the types of firewalls, their benefits and their limitations, and finally, their role in modern layered network security systems. Introduction. When data moves across networks, it passes through various devices, routers, and sometimes even internet routes. During this journey, it can be intercepted, modified, or misused by attackers if not properly protected. To prevent such intrusions, firewalls act as the first line of defense. They are positioned at boundaries between an internal trusted network and an untrusted external network, typically the internet. You can imagine a firewall as a digital security guard that checks every piece of data entering or leaving a network and decides whether to let it pass or block it. The overall aim of a firewall is to provide control and visibility over network traffic to make sure that only safe, expected, and authorized communication occurs. Now, let's define it more precisely. A firewall is a network security system, either hardware, software, or a combination of both, that monitors and controls network traffic based on a defined set of security rules. It essentially creates a barrier between trusted internal systems and the external untrusted sources. Think of it as similar to the security check at an airport. Every passenger, or in this case, every data packet, must be checked according to security rules before being allowed in. If a data packet matches the rule set, it's allowed to pass. If not, it's rejected. The concept may sound simple, but it forms the foundation of nearly every secure network architecture in today's use. The main objective of the firewall. It aligns with the fundamental goals of the network security, which is confidentiality, integrity, and availability, often called as the CIA triad. Confidentiality ensures that sensitive data is not accessed by unauthorized users. Integrity means ensuring that the data has not been tampered with. Availability guarantees that authorized users have reliable access to the service and data they need. Firewalls help achieve these by controlling access, filtering malicious traffic, and blocking intrusions. They also support user authentication, logging, and auditing, all of which are important for maintaining accountability and transparency in a secure system. Now, let's discuss the conceptual working principle of a firewall. Every packet of the data that ensures or enters or leaves a network is examined by the firewall. It inspects key attributes such as the source and destination IP addresses, port numbers, and the type of protocol that is being used. They are compared against a set of predefined security rules created by the network administrator. If a packet matches an allow rule, it passes through. If it matches a deny rule, it is blocked. If it doesn't match any rule, the default action is usually deny all is applied. In essence, the firewall enforces an organization's network security policy automatically and consistently 24/7. Next, there are several type of firewalls and each one works at different layers of the network model. The most common types include packet filtering firewalls, which is simple and fast, working mainly at the network layer. The second one is stateful inspection firewalls, a more advanced understanding ongoing sessions. The third one is proxy firewalls, act as the intermediaries between users and the external systems. The fourth one is next generation firewalls, which is shortly called as NGFW, which is modern intelligent firewalls that combine multiple features. Now let's see the types one by one. The first one is packet filtering firewall, which is the oldest and simplest form of firewall technology. It checks each packet header's information, that is, where it is coming from, where it's going, and what protocol it uses. If the packet matches allowed parameters, it is forwarded. If not, it is dropped. The biggest advantage of packet filtering firewall is their speed. They process packets quickly because they only look at basic informations. However, they don't understand the context or the state of connection. This means they can't tell if a packet is a part of a legitimate session or not, which limits the protection level. The next type is the stateful inspection firewall. This improves upon packet filtering. It keeps track of active connections and builds a table of ongoing sessions. When a new packet arrives, the firewall checks whether it belongs to the existing valid session. If it does, the packet is allowed through automatically. This feature provides more context and control, making it more secure against certain type of spoofing or unauthorized connection attempts. The stateful inspection became the standard for enterprise firewalls for many years because it strikes a good balance between performance and protection. The third type is a proxy firewall. It works at the application layer. Instead of directly connecting to an external service, internal users connect to the proxy, which then forwards a request on their behalf. This hides the external internal network structure and adds an extra layer of anonymity and filtering. It can also examine the contents of data, for example, blocking specific websites or malicious attachments. Proxy firewalls are slower because they process more data, but they are extremely valuable for organizations that prioritize privacy and detailed content control. The last one is the next generation firewalls. This combine traditional features of stateful inspection with more intelligent capabilities. They can detect and block sophisticated threats by using deep packet inspection, application awareness, and even intrusion prevention systems. The NGFWS can recognize which applications are generating traffic, not just ports or IPs, and apply security policies accordingly. For example, they can differentiate between legitimate web traffic and malicious script hidden in the web requests. They represent the modern evolution of firewalls built to handle today's complex threats. Next, we are going to see the firewall policies and rules. Firewalls operate based on rule sets and policies. They are written and maintained by network administrators to align with organizational needs. A policy might allow web browsing through ports 80 and 443, but block unauthorized remote access or file transfers. Effective firewall management means keeping these policies updated, avoiding conflicts between rules, and reviewing logs to identify abnormal activities. A well designed policy is the backbone of reliable firewall. That is even more important than the technology itself. Next, the advantages of the firewall. Firewalls offer several key benefits. They block unauthorized access, ensuring only trusted communication occurs. They monitor and log all traffic, providing visibility into network activity. They help prevent malware and ransomware attacks by filtering malicious traffic. They also support compliance with organizational and legal security standards. The most importantly, firewalls create a layered defense strategy. That is a key principle in cybersecurity that ensures no single point of failure. Of course, the firewalls are not perfect. They cannot stop internal misuse. For example, if a legitimate user behaves maliciously, they also cannot prevent attacks that only rely on internet, like social engineering or USB-based infections. Firewalls need constant updates and tuning to stay effective. Attackers continuously invent new methods to bypass them, so administrator must stay proactive. In short, firewall is a strong gatekeeper, but not a complete security solution by itself. Role in overall network security. In a modern security architecture, then firewall is one of many layers. It works alongside intrusion detection systems, shortly called as IDS, and then intrusion prevention systems, shortly called as IPS, then virtual private networks, shortly called as VPNs, and antivirus programs. Together, they create a defense in depth approach where if one layer fails, others still protect the system. The guiding philosophy behind all firewall setups is default deny. That means everything is blocked by default and only known safe traffic is allowed through. This principle minimizes the risks that network access is strictly controlled. Conclusion. To summarize, firewalls are among the most essential and enduring components of network defense. Even as technology evolves, the core idea, inspecting and filtering traffic, remains the same. They enforces the boundaries of trust, protect sensitive data, and prevent many cyber threats before they can reach internal systems. However, as we have seen, they are not a one-step solution. They work best as part of a large layered security strategy. In simple terms, a firewall is not just a tool, it's a guardian of digital boundaries, a silent protector that allows us to use the internet safely and confidently. So this is it. Thank you very much.